Hello students, in this video lecture I am going to discuss about the basic concepts of the scattering of light and the Tyndall effect. Scattering is a natural phenomenon. So the phenomenon of redirection of light ray due to interaction with air molecules or colloidal particles is known as a scattering of the light. So the phenomenon of redirection of light ray due to interaction with air molecules or colloidal particles is known as a scattering of the light, or the phenomenon of a scattering of light by the colloidal particles due to which the path of light is clearly visible is known as the Tyndall effect. So Tyndall effect is the phenomenon of a scattering of light by the colloidal particles due to which the path of light is clearly visible is known as the Tyndall effect. This phenomenon or Tyndall effect can also be observed through a canopy of dense forest, or in a smoke dark room when light ray enters through a small hole. So the scattering of light we can observe in a smoke filled room when light ray enters into the room through a small hole. So it can also be observed in a dark filled room or through the canopy of the dense forest. So the Tyndall effect is the phenomenon of the scattering of the light through the colloidal particles due to which the path of light is clearly visible, or it can also be observed through the canopy of the dense forest or in a smoke filled room that enters when light ray enters through a small hole. So Tyndall effect is the phenomenon of the scattering of the light. So the intensity of the scattered light, that will depends on the two factors. So the factors on which color of the scattered light depends. So first of all, the size of the scattering particles. The color of the scattered light depends on the size of the scattering particles. If the scattering particles is very fine, that scatters colors of the shorter wavelength, as for examples violet, indigo and blue. If the scattering particles is large, that scatters color of the longer wavelength, and that is red. And if the scattering particle is very large, that scatters all colors equally and appears white. So there are two factors on which the color of scattering light depends. So these two factors are size of the scattering particles and second, wavelength of scattered light. So these are the two, wavelength or the color of the scattered. Now note here. So that will be the question generally arises, how the color of the scattered light depends on the size of the particles of the medium or the scattering particles. If the size of the scattering particle is very small or very fine, then it scatters color of the shorter wavelength, that is violet, indigo and blue. If the scattering particle is large, then it scatters color of the longer wavelength, that is ray, or if the scattering particles are very large, then it scatters all colors equally and appears white. So now according to Rayleigh, the intensity of the scattered light, the color of the intensity of the scattered light depends on the wavelength of the light, and Rayleigh observed that the intensity of the scattered light is inversely proportional to the fourth power of the wavelength of the scattered light. So I is inversely proportional to the lambda to the power 4. So according to the Rayleigh, the intensity of the scattered light is inversely proportional to the fourth power of a scattered light, wavelength of the scattered light. So now Rayleigh observations. Now one note here we will also discuss. According to Rayleigh, R-A-Y-K-V-I-G-H, Rayleigh, the intensity of a scattered light is inversely proportional A scattered light is inversely proportional to the fourth power, of wavelength, of a scattered light. Fourth power of wavelength of a scattered light. It means that I is inversely proportional to the lambda to the power 4. So the color having shorter wavelength scatter more than the color of the longer wavelength. It means that the violet, indigo or blue colors scatters more than that of the red color, because the violet colors have less wavelength than that of the red color. So red colors scatters least and the violet color scatters most. So the colors having shorter wavelength, that scatters least, and the colors having longer wavelength, that scatters most, and the colors having longer wavelength, that scatters least. So the violet, indigo or blue scatters most and the red colors scatters least. So there are many phenomena based on the scattering of the light. So the phenomena based on scattering of light are the phenomena based on scattering of light. So the phenomena based on scattering of light. The phenomena based on scattering. First is the sky appears blue. This is due to the scattering of the light. So first phenomenon is appearing the color of the sky. So appearing blue color of the sky. First phenomenon is appearing blue color of the sky. Blue color of a sky. Or the second phenomenon. First phenomenon appearing blue color of the sky, or the second is appearing reddish color of the sun at the time of sunrise or sunset. So second appearing reddish color